Okay, so we've done these first 5 questions. Now we're moving on to the 6th one, which I have copy pasted over here. So this is the question we're doing. And I also have question 5 copy pasted because I wanted to mention something. So as before, we're asked to prove if the language is regular or not. Let's first go over what the language is. So it's all strings over alphabet A, B, where the string starts with some number of A's, then it has a B in the middle, and then it ends with the same amount of A's as we had at the start. And the amount of A's that we can have on either end is n, where n is a number, an integer, between 0 and 5 inclusive. And what we can notice is that this language is really similar to the one that we did before. So question 5. Only we've swapped the zeros for A's, the 1 for B, and we've changed k from being greater than or equal to 0 to being in between 0 and 5. So before k could be any value greater than or equal to 0. So it could be 1,000,000 or 1,000 or whatever, but now n can only be these numbers. So because these languages are so similar, and if you remember, this one was not regular, you might think that this one down here is also not regular. But that's actually not the case. This language down here is in fact regular, and that's because it's a finite language. Any finite language is always going to be regular. That's something you need to remember, like understand. So, looking at this language, you might ask yourself, how do you know it's finite? Well, if you look at the values that n can take up, it's within a range, right? So, n can be any of these numbers. N can be 0, 1, 2, 3, 4, or 5, because all of these numbers are between 0 and 5 inclusive. So n can't be any other number. And so if we look at the strings that we can get for each of these values of n, for example, if n is 0, what string do we have? We'll have a to the power of 0, b, a to the power of 0, just subbing in that value for n. If a is 1, then we'll have, sorry, if n is 1, we'll have this. If n is 2, we'll have this, and so on. Let's quickly write out what the strings are. So any string to the power of 0 is going to be epsilon. And so this is the same as b. Then this one over here is ABA. This one has 2 A's at the start with a B, and then 2 A's. This one has 3 A's at the start, and then this. Okay, so these are all the strings that we can have in this language, because we have no other values of n that we could possibly have. And so the string has 1, 2, 3, 4, 5, 6 different strings. So the amount of strings within this language is 6. And so the language is finite. It's not an infinite language. Therefore, it must be regular. And so there must exist a DFA/NFA for this language. And so we need to construct one. So we know it's regular. All that's left is to make a DFA/NFA for it. So whenever you have these really, really small languages, there's a nice way of creating an NFA for it. So a DFA for this language will be a lot more complicated than NFA. So we want an NFA that accepts any of these strings, right? So what we can actually do is first create an NFA for each of these strings individually. Okay? So let's pretend that we have those NFAs. Let me just quickly draw out boxes. So this will represent an NFA that accepts B. Okay? This will represent an NFA that accepts ABA. And so we'll have hypothetical NFAs for each of these, right? So if we were to create these NFAs, what we would need to do to create like one big NFA that accepts all of these is just create an extra start state that then epsilons into each of these NFAs. And so what would happen when the NFA, like the big and main NFA, reads the string? It will sort of know which path to take, which NFA to go to accept the string. And so this NFA, which is made up of a bunch of smaller NFAs, will accept any of these strings. So let's like do that then. Let's create an NFA for each of these strings individually first. Let's do one for B. So remember that NFAs can have epsilon transitions. They can have missing transitions, which are implicitly trash states, and they can also have multiple transitions with the same character from the same state. So let's make an NFA for B. We have a start state. Then when we read in a B, we go to an accept state. There we go. And that's it for the string. We've done it for the string. Let me quickly make it smaller just so it's less messy. There we go. Let's quickly go over some example strings. So say we read in a B. Would it accept it as we want? Well, we start in QStart, read in a B, go to accept. So it would accept B. Say we had AB. Would it accept this? We start in QStart, read in an A. There's no transition, so we go to the implicit trash state, so it rejects this one. What about BA? It would read in a B, go to QAccept, then tries to read an A, but there's no transition, so it goes to an implicit trash state. So we've successfully created an NFA for this string. Let's now do an NFA for the next one, which is ABA. Okay. Now we can have a star state, which will make the star state have a different name to the other one. We'll just say QS2. And now we want to accept ABA. So we can just do it like this. Sorry, like this. Okay, so this NFA will only accept the string ABA. Now we make another NFA, but for the next string, so this one. So we've done one for this, done one for that, just need the third one. So it's going to be very similar. We need to make sure that the states have different names. Okay, we can't have the same state name, so we're just going to put Q, Q1. Okay, so AAB. Okay, and then this should be an accept, right? Yep. Okay, we've made an NFA for this one. Now we need to make NFAs for all the others. So in the interest of saving time, I'm just going to copy paste this and then extend it. So like this. So we can do something like this. A, have a new state. I'll just call it QZ. We'll rename these states. Okay, this is getting really messy, but just just ignore it. Okay, this is super messy. Okay, now we have an NFA for this string. A, B, A. Okay, now I could write out the NFAs for these, but I feel like that's going to take a lot of time and look really messy, so I'm just not going to do that. So let's pretend like we do have those NFAs. Okay, I'm just going to represent them with these two boxes. And this has like a start state. Okay, so now we have an NFA for each of the strings that we wanted to accept. And so what we do is we create a start state for our main NFA. And then we epsilon transition into the start states of all of our smaller NFAs. Sorry, this is supposed to be epsilon. So again, these are supposed to be NFAs, we just haven't written them out. Okay, there we go. Now whenever this NFA, this huge NFA, reads in a string, it's going to magically know which NFA to go to, and it'll see if it accepts. So if any of these go through the machine, it'll accept it. And so we've created an NFA that accepts exactly this language, and therefore it is regular. Okay, I hope that made sense. So for example, if we read an ABA, we would start in this state, and we'd magically know that this is the path we should go to. And then we read ABA and we accept. If we had AAB, AA, we would start in main, we'd magically know to go to this NFA over here, and then we'd read it and accept. And the same for any of these other strings. Okay, on to the next question.